What's up? I'm Vin, and today I want to take a look at recursive sequences. So here's a nice definition for recursive sequences, and the first example that we'll look at is, let's say I let a sub 1 equal 1, and a sub n, that's the general term, is going to be 3 times, and we'll have a sub n minus 1, and then we'll have plus 2 attached to it like this. So the way that I like to deal with these type of sequences is that I look at the a sub n minus 1 term, and I describe it in my head as this is the term before a sub n. So let's say here I want to find the first 5 terms. Then a sub 2 would be equal to 3 times, and notice here this corresponds to n equals 2. So if I do this by substitution, this would just be a sub 2 minus 1, which is a sub 1, plus 2. But notice what I said before, this is the term right before a sub n. So if I'm looking for a sub 2, the term right before it is a sub 1, which they told us is equal to 1. So this is going to work out to 3 times 1 plus 2, and this is going to give us 3 times 3, which is equal to 9. So now this is our second term. So to find our third term, we use this formula. We're going to have 3 times, and a sub n minus 1 is, remember, it's the term before a sub n. So if I'm looking for a sub 3, then I'm going to use the term that I just found before, which is 9, and I'll have 9 plus 2 equals 11, and then 3 times 11 is going to give us 33. So if we just continue down the list here, what we're going to do is we're going to find a sub 4, and for a sub 4 we're going to use the same formula, 3 times blank plus 2, but remember a sub n minus 1 is the term right before a sub n, but I'm looking for a sub 4, so the term right before that we found was 33. So we plug this in, this is going to be 3 times 35, which is going to give us 105. And now for the last one here, I have 3 times parentheses blank plus 2, and I'm using the term before, which is 105. So then we just work this out. This is going to be 3 times 107, and that's going to give us 321. So here are the first 5 terms of the sequence. If I want to list it, the first term was 1, the second term was 9, then we got 33, we got 105, and we got 321. So let's look at another recursive sequence. So this time we'll let a sub 1 equal 1, and the nth term is going to be 1 over 1 plus a sub n minus 1. And from here we want to find the first 5 terms. So to find a sub 2, once again, I could do everything by substitution and say n equals 2, and that's going to give us 1 over 1 plus a sub 2 minus 1 is going to give us a sub 1, and then when we make the substitution, we're going to get 1 over 1 plus 1, which is equal to a half. But once again, anytime I look at this term, I tell myself that, let's say in the case where I want to find a sub 3, I'm going to have 1 over 1 plus a sub n minus 1 is the term that we just found before. So the term that we just found before was 1/2. So then that would go next. And then when I want to find a sub 4, I'm going to have 1 over 1 plus whatever this works out to. So if we work this out here, this is going to be 1 over, this is 2 over 2 plus 1 over 2, which is 3 over 2. And then this works out to 2/3. And then that's going to go here. The 2/3 is going to go here next. And then I have 1 over, this is 3 over 3 plus 2 over 3, which is going to give us 5 over 3. So then we flip this, and this is going to work out to 3/5. So if we just continue here, now we want to find the 5th term. It's going to be 1 over 1 plus, and we write the fraction that we just found, 3/5. And if we work this out, this is going to be 1 over 5 plus 3 over 5 is 8 over 5. So this tells us that a sub 5 is equal to 5/8. Now, if I write these numbers out, my first term was 1, second term was a half, then we had 2/3, then we had 3/5, and then the 5th term, we had 5/8. If you don't recognize these numbers, these are actually very special numbers. These are the Fibonacci numbers, which will be a perfect segue to the next example because we'll explore the Fibonacci sequence in greater detail. Now, it would be hard to make a video about recursive sequences and not mention the Fibonacci numbers. So here's the recursive sequence for the Fibonacci numbers. The nth Fibonacci number is equal to the sum of the 2 previous Fibonacci numbers. And we start off here by saying the first Fibonacci number is 1. And we could say the second Fibonacci number here is also 1. So then when we want to find the third Fibonacci number, then that's just going to equal, this is once again n equals 3. That's going to equal f of 3 minus 1 is 2, plus 3 minus 2 is 1, so we'll have f sub 1. So f sub 3 is going to be equal to the sum of these two Fibonacci numbers, and we're going to have 1 plus 1 is equal to 2. So now when we want to find the fourth Fibonacci number, this is going to be equal to the sum of the third Fibonacci number and the second Fibonacci number. And if we just use the two previous ones, we're going to have 2 plus 1, which is going to work out to 3. And then we just continue this pattern here. Notice I'm just going to add the two previous ones. I'm going to have 3 plus 2 this time. It's going to work out to 5. And I could continue this. Let's say I want to find the first 11. 5 plus 3 is going to work out to 8. And then we just continue this pattern. The seventh Fibonacci number, we could write over here 8 plus 5 is equal to 13. And then we have the eighth Fibonacci number. We're going to have 8 plus 13 is equal to 21. And we're going to need a little bit more space here. So let's see, the ninth Fibonacci number, we're going to have 13 plus 21 is equal to 34. And if we just go two more, the 10th Fibonacci number, we add these two, we're going to get 55. And the 11th one, we're going to get here out to 89. So if we want to write these in a nice list, think about what we started with. We had 1, 1, and then 1 plus 1 was 2. We add those two previous numbers to get 3, 5, 8, 13, and then just completing this list here. Okay, so these were the 11 terms of our sequence. But remember, this list could just continue forever. We just have to keep adding the two previous to generate the last, or to generate the next.